Problem 5.21. In the figure, the coefficient of kinetic friction between the surface and the larger block is 0.2, and the coefficient of kinetic friction between the surface and the smaller block is 0.3. If F is equal to 14 newtons and M is 1 kilogram, what is the magnitude of the acceleration of either block? Again, like the last problem, these two are connected together, and so they're going to move with the same acceleration. We have that M is 1 kilogram, so mass 1 is actually 1 kilogram, and mass 2 is actually 3 kilograms. And we're going to have two frictional forces, little f1 and little f2, working separately on these two masses. Little f1 is going to equal mu1 mass 1g, and that's going to be equal to 0.3 times 1 times 9.8, and that's equal to what? 2.94 newtons. And little f2 is going to be mu2 mass 2g. That's going to be 0.2 times 3 kilograms times 9.8, and that's equal to 5.88 newtons. Alright, everything's going to work together, move together. So if we did a glob of the whole thing, total mass of 4 kilograms, we'd have this pulling force F of 14 newtons at the front. We have these two forces, F1 and F2, against the motion. Of course, we'd have a normal force, and we'd have a weight force, but those are going to be transverse to the motion, so they're not going to come into play other than helping us, the weight helping us with the calculating the frictional forces. And everything's going to ultimately accelerate to the right. So based on the motion in the direction of acceleration, we have the summation of all the forces in the x direction is equal to our total mass times A, and that's equal to F minus little f1 minus little f2. That's going to be 4 kilograms times A is equal to 14 newtons minus 2.94 minus 5.88. So we have that A is equal to 5.18 divided by 4, or that's equal to 1.295, so we'll say 1.30 meters per second squared. So the acceleration of both blocks, since they're connected, is 1.30 meters per second squared to the right.